Assalamu alaikum everyone. I've been finding many students having difficulties on how to know the limits of certain equation. Sometimes we know that limits, these are the ranges given for a certain equation, or the ranges or limits given to a certain function. But most of students have difficulties on determining the limits under which an equation ranges from. Now, today I'm going to prepare this video to make you understand these limits. So the limits of these equations are x approaching infinity, or x greater than or equal to 0. Now, what to ask yourself is that what is happening as x approaches infinity first? What is happening to this equation or functions? Also, what to know here is what happens to those functions as x approaches 0. So I'm going to show you one by one. For example, given a function like 1 over x, what is happening to this function as x is approaching infinity? What is happening? Sometimes you may be given a function in this way, x raised to power negative 1. Remember, x raised to power negative 1 is the same as 1 all over x power 1. That is mathematically correct. So now let's do the limits of this function as it approaches infinity. What is happening to this function? We have our calculator here. Now, for example, let's start from smaller value proceeding to larger value. So let x be, what if x equals to 10? So it will be just 1 over 10. What is the result? Take your calculator, just key in 1 over 10. This in decimal, let's give us a decimal which is 0.1. So let's keep on approaching infinity. Now let's take 1 over 100. What is happening to that function? Now is 0.1. Now, what is 1 over 100? Key in 1 over 100. The result is 0.01. Now, let's take x being 1000. 1 over 1000. What is happening to this function as x keeps on approaching infinity? So it will be just 1 over what? Over 1000, which gives us 0.00001. Now let's take 1 over 10,000. Let's end up here, and then we will just briefly know the limits of that function. Now, what is 1 divided by 1000? 1 divided by 1000, when you use your calculator, is just 0.00001. 1, 2, 3, 4, 5. So it's 0.001. So we can conclude that the function of 1 over x, or x raised to power negative 1, as x approaches infinity, the limits of this is approach is the function keeps on reducing, approaching 0. So we can conclude the limit of 1 over x as x equals to approaches 0. The limit of this function equals to what? Equals to 0. I think we are all together there. So let's proceed to the next function, which is 1 over e raised to power x, or e raised to power negative x. So as x now approaches infinity, what is happening to that function? So remember that as x approaches infinity, so it will be just 1 over e raised to power infinity. As x keeps on increasing, now let's prove it. The limits of 1 over e raised to power x as x approaches to infinity is just equals to 0. But how? Let's come and begin showing it up. So suppose x equals to 10. Therefore, 1 over e raised to power 10 equals to what? Yes, let's proceed. You just put key in 1, as shown there, over exponential, just shift exponential. Since our exponential here is already raised to power, you can see it, there's no need for you to just raise it to power. Just exponential raised to power 10. What is the result? This is, you can see, is 4.5 times 10 raised to power negative 5. We can see power negative 5 is like 0.000 something. Now, what happened as it approaches infinity? X. So let's assume x equals to 100. What is going to happen? So key in 1 over 100, not 100, but shift exponential power 100. That's just, you can see, is raised power negative 4. So it keeps on approaching 0 and 0 and 0. So since this is 3.7 times 10 raised power negative 4. So negative 44, we can see this equation keeps on approaching 0. So that's why we are saying that the limits of such a function, either we given this form. Remember, when you are given a function this form, it's just the same as writing it in this form. So the limit of this function as it approaches to 0 is automatically 0. Let's wind up with this function, given a function like that. So for example, given a function x equals to e raised to power negative x, this is just the same as x all over e power x. Now, what is happening to this function as it approaches infinity? What is happening to this function as it approaches infinity? As x approaches infinity, what is happening to that function? Now, when x keeps on approaching infinity, and e approaches infinity, when x approaches infinity, e raised to power infinity is automatically infinity. Is infinity. So we can see here, e raised to power 100 is very large, very large. E raised to power 1 million, just very, very, that's infinity. When you keep on approaching infinity, the function of e raised to power x is just infinity. Also, as x approaches to infinity, as x approaches to infinity, this result here becomes infinity over infinity. But infinity over infinity is indefinite. In limits, that is indefinite. You can't get the result of that. Now, what should you do to such a function? So what to look there is which equation grows faster than the other. What to know? you have to determine the equation that keeps on growing faster than the other. Now, let's take an example. To me, I just say that the limits of x over ex as x approaches to infinity, this is automatically 0. Why? That function keeps on reducing instead of increasing. Why? As x, you know, the function of exponential raised to power x and x, this function, the lower function is the one which grows faster. When the denominator grows faster, meaningly the function, even if this one also keep on growing but very slowly, the function becomes 0 because this one, it will keep on reducing this function. When this lower function grows faster, then it keeps on reducing that function. That is what we have to know. Which function grows faster than the other? We know that e raised to power x grows faster than the other. How? Let's take an example that x when x equals to 10. So when x was 10 to be e raised to power 10. Therefore, 10 over exponential raised to power 100 is 3.7 power negative 43. Can't you see there? It's power negative 43. So let's just write it in short form, 3.7 times 10 raised to power negative 43. Now, what is happening? I was supposed to write it power 10. I'm sorry, power 10, but not power 100. So let's take 10 over shift exponential power 10. What happened in that function is power negative 4. So it's 4.5 times 10 raised to power negative 4. Now, what happens when x is 100? 1 over e raised to 100. So we can say that the lower function grows faster than the upper function as x approaches infinity. So let's take 100 divided by exponential shift power 100. So you can see that since the lower function grows faster, the result of that function or the limits of that function keeps on approaching 0. You can see there power negative 42. So the result is just 3.72 times 10 raised to power negative 42. What is happening to this function as it approaches infinity? We can see the result of that function keeps on reducing. That's why we can conclude that. So given a function like this one, or like this one, as x approaches infinity, the result is just 0. Then why do we say that the exponential of e raised to power x over e raised to power x, the law of e raised to power x, the exponential function grows faster? Let's come here. As x equals to 100, what is e raised to power x? Raised to power 100. So we just click in or key in e raised to power 100. What is that result? Can't you see the power? If this is 100, this is 2.6 times 10 raised to power 43. Can't you see this is very large value compared to this one? So we conclude what to know in such a function, in this function with quotients, is to ask yourself which function grows faster than the other. Hence, it will be easy for you to determine the limits of that function. So when my video are helpful and you understand, so I'm waiting for your comments on how or where to improve my videos. And when they are helping you my videos, I'm going to provide more and more videos and the limits. So just subscribe and switch on the notification tab for notifications after or in each and every upload I'll be making. So welcome to my channel and feel free, just waiting for your comments. So thank you very much.